Good afternoon, everybody. Myself, Akshay, I am senior lecturer at Government Polytechnic College for Girls, Jalandhar, and today I am here to discuss color TV under subject consumer electronics. So, our topic of today is color television. What are the main constituents of color TV? Before discussing color TV, we will have to know about color TV, and these are the outlines of the lecture what we will be discussing today. First of all, we will be discussing introduction to color TV, what the color TV is, then compatibility of color with monochrome. We already have discussed, most of you must have gone through the monochrome TV system. So, we know what the monochrome is. There we see information in black and white. So, there are only two coordinates, black or white, but in color we have various colors which are formed with the combination of some colors called primary colors. So, how this color TV system is compatible with the monochrome? Compatible means both the system can be operated on the same receiver, the transmitter as well as receiver. If it is color, it can be received in black and white or monochrome. If it is monochrome, should be able to be received on color raster. So, this is compatibility. So, how these systems are compatible, whether they are compatible or not, and if yes, then how, and what are the reasons why they are compatible, and what are the various requirements which are there for compatibility, and how these two systems fulfill those requirements, so that they become compatible. Next, we will be discussing color television system. There are three basic color TV systems. So, we will be discussing them. Then three color theory, how the colors are formed. There are three colors. By combination of these three basic colors, we get different colors. So, various colors are formed by the combination of those three colors. It depends upon the proportion. We will be discussing all that. Then characteristics of color. What are the characteristics of colors? How the colors behave? How they appear as if we see a particular color of a particular tint, why it appears so. So, that will be discussing what are those characteristics. Then color TV camera tubes. Camera tube is the tube with the help of which we pick the pictures. So, color TV camera tubes, and then we will be also discussing those picture tubes also. So, first introduction. Color TV system send following information. Number 1, color and brightness information of scene. Second, sound associated with scene. So, as monochrome TV sends monochrome information, here color TV sends color information, and along with that color information, it sends the corresponding brightness information also of a particular color. Suppose a picture is combination of various colors. So, every color has got its own brightness level. So, when we send the signal, we send signal in terms of, not in terms of color only, but in terms of associated brightness also. Every color has got its own brightness, and whenever we send color signal, we send color signal along with its associated brightness information. So, that makes the complete picture. And the second part is sound associated with the scene, same as in the case of monochrome. In color TV also, we send the sound associated with a particular scene along with the scene. Next is compatibility. This is very important, and perhaps the most important part of your TV system when we talk about the color TV system, because when we talk about color TV system, it is not only color TV system which we will be discussing, or which we go through. It is also the monochrome counterpart of it. that how monochrome system works and how is it different from color, and what are the similarities between color TV and monochrome TV, and how they can be correlated to each other, how the signal can be processed in both of them, so that if an information is of black and white form or monochrome form, that can be displayed in on color rasters or receivers, and vice versa. Means if it is a color information, that should the receiver which is monochrome should be able to display that color information in corresponding black and white brightness information of that. So, this is very important part, compatibility. So, under this what the compatibility means? It means number 1, the color television signal must produce a normal black and white picture on a monochrome receiver without any modification of receiver circuitry. Means if it is color TV, it must produce a black and white picture. It must produce a black and white picture if the receiver is monochrome, and to do so it should not require any additional circuitry or any modification into the circuitry. So, this is one part. Second, color receiver must be able to produce a black and white picture from a normal monochrome signal. This is referred to as reverse compatibility. Means as we discussed, if it is monochrome receiver and signal is color, that signal should be displayed on monochrome receiver without any modification, without any additional circuitry. So, this is one part. This is called compatibility of monochrome receiver with color signal or color transmitter. But the reverse should also be true. Means if it is color receiver and the picture being televised or the picture collected and then televised is monochrome, means it contains only two coordinates, only two signals, means black and white, then that should also be able to display it on the color raster or color receiver. Means color receiver should be able to display the signal even if the input signal is not color signal, it is monochrome signal. So, if this happens, this is called reverse compatibility. The earlier stage we call compatibility, and if color receiver shows this characteristic of displaying monochrome information on color receiver, then that will be referred to as reverse compatibility. How it can be achieved? What are the prerequisites, requirements of compatibility? To achieve this, that is to make the system fully compatible, the composite color signal must meet the following requirements. There are certain requirements which the composite signal should meet with if the compatibility is to be achieved. What those requirements are, we will be seeing them one by one. The first one is it should occupy the same bandwidth as the corresponding monochrome signal. Means the bandwidth of color as well as monochrome signal must be same. There should not be any difference between bandwidth of color and monochrome signal. Second, the location and spacing of picture and sound carrier frequencies should remain the same. Means where a particular signal is placed within the band should be same for both monochrome as well as color TV. They should acquire the same position, they should be similarly located. It should not be a different position if it comes to color TV and if a different position if it is monochrome TV signal. In both the signals they should occupy the same location, the same position. Number 3, the color signal should have the same luminance, that is brightness information, as would a monochrome signal have, transmitting the same scene. When same scene is being transmitted, then color signal should have same luminance, which is brightness. In case of monochrome TV we say brightness, if it is color TV we call it luminance also. So, it should be same, whatever the case may be, whether it is color or it is monochrome. In both the cases the brightness or luminance should be same, irrespective of the system, whether it is monochrome or it is color system. Next, the composite color signal should contain color information together with ancillary signal needed to allow this to be decoded. Now, what the composite color signal is? Composite color signal is a signal which contains color information along with other informations. What the other informations are? In monochrome TV we have seen that it is not only the signal, but there are other signals also. For example, there are sync pulses, not only video signal, apart from the video signal which is being generated from the optical information is converted into corresponding electrical signal. So, when it is converted into corresponding electrical signal, it is not transmitted and received as such. Whatever the signal has been created, we transmit it or we receive it. It is not the case. Actually, what happens, to transmit it or even to collect the information and to display the information, we require some additional signals also. What those additional signals are? For example, additional signal is that we have blanking pulses, which are required to blank down the period when it is retrace, means whether it is horizontal retrace or vertical retrace. In both the cases we have to hide the process, and we do it with the help of blanking pulses. Then we have sync pulses, right, for the purpose of synchronization, whether it is for horizontal sweep oscillator or for vertical sweep oscillator, we require sync pulses. Then we have sound signal. Okay. Apart from that, we have our equalizing pulses, pre-equalizing and post-equalizing pulses, and so many other signals are present there. Along with those signals that forms the color signal, we have an additional signal, that is color signal. So, this color signal is added to that already existing signal which we have in monochrome. What we have in monochrome will be having in color also, the same will be having in color, but apart from this we will be having an additional signal which is color information. So, it is added to that color information or color signal, and in fact, it is multiplexed, and to do so we require another signal which is ancillary signal. Ancillary signal means the signal for color introduction, means what that signal is? Encoding signal. The signal required for encoding the color. When we add the color, means we do it with some coding. So, that is encoding, and when we receive the signal we decode it. So, those signals should also be present. Next, the color information should be carried in such a way that it does not affect the picture reproduced on the screen of a monochrome receiver. So, this is obvious requirement. Whenever we send the color information along with monochrome signal, we should send that information in such a way that it does not affect the monochrome receiver if the receiver is monochrome and signal is being received there. So, the color signal present in the signal should not interfere with the monochrome information, so that it will not affect the signal when it is reproduced on the monochrome receiver. The system must employ the same deflection frequencies and sync signals as used for monochrome transmission and reception. So, when monochrome transmission and reception we do, we use some signals which are called sync signals. So, these sync signals should be unaltered, they should remain same whether it is monochrome or it is color. Sync signal should not change, otherwise the information, if they are different, the information on color signal will not be displayed on monochrome and information of monochrome will not be displayed on color. So, to ensure this, that both the informations are displayed on both type of the receivers, what we require, the very important requirement is that sync signal should be same in both the cases. In order to meet the above requirements, it becomes necessary to encode the color information of the scene in such a way that it can be transmitted within the same channel bandwidth of 7 megahertz and without disturbing the brightness signal. So, to meet these requirements, what becomes necessary, it is necessary is that we should encode the color information and we should do it in such a way that it can be transmitted within the same bandwidth. So, what the bandwidth is, channel bandwidth for the system is 7 megahertz. So, it should be transmitted within the same bandwidth, and when it happens, it will not disturb the brightness of the monochrome signal. Similarly, at the receiving end, a decoder must be used to recover the color signal back in its original form for feeding it to tricolor picture tube. So, what we have in color TV is a tricolor picture tube. So, at the receiving end, that is in the receiver, we should have a decoder, and decoder should be such that it should be capable of decoding the color signal. Decoding means some signal is added to the already existing monochrome signal. So, it should be able to decode that signal separately without affecting the other signal, and after decoding it should be able to feed that signal to the electron guns of the tricolor picture tube, which is the basic difference between monochrome and color TV. This is signal transmission path which shows the compatibility between color and monochrome systems. R, G and B, red, green and blue, these represent 3 camera tubes which develop video signal corresponding to red, green and blue contents of the scene being televised. So, this you can see this is a monochrome receiver, and here we have the color receiver. So, whatever the object is, how the signals are transmitted and what the compatibility is, that first we discuss monochrome. In monochrome, we have monochrome camera, this is the object. So, the optical information of this object which is the reflection of from the surface falls on the lens, and from here we convert it into corresponding electrical signal, and those electrical signals are transmitted. This box shows the transmission path. When we transmit the signal through transmitting antenna, then here we receive the monochrome receiver through receiving antenna, and after reception this monochrome receiver gives it to electron gun, which is a single gun, and here we have phosphorus screen. So, this optical information is converted into corresponding electrical information, transmitted, received here. After reception, this electrical signal is fed to the electron gun as input, and from electron gun what we have a specific number of electrons emitted depending upon the input signal, and those electrons when with this sufficient or optimum velocity travel and strike with the phosphorus screen, they produce a spot of light. So, in this way optical information converted into electrical, corresponding electrical information is again converted into optical information. So, this is the complete television system. In this way it an optical information after getting picked from a particular place can be reproduced on the raster or screen of the monochrome TV. Now, we see what happens in color TV. In color TV, what we have object, and from the object when light is reflected, the light from when we see particular colors, color means that that particular wavelength or frequency is being reflected and other wavelengths are absorbed from that surface. So, that color or that particular signal when falls on this color filter, these are called optical filters. So, when it falls on this filter, a particular wavelength is allowed to pass through it and all other wavelengths are rejected here. So, the purpose of using color filter is that if it is for R, it will allow only the wavelengths corresponding to red color to pass through it. Of the scene, out of the scene only red color will pass through and remaining will be rejected. So, here what appears is red information of the scene of at a particular moment. Similarly, here this color filter will or optical filter will allow only green wavelengths signal to pass through it, and this will allow blue to pass through it. So, this VR, VG and VB is nothing but voltage corresponding to red, green and blue colors, and then here they are mixed with the help of a combining or mixing network, which is called a combining matrix, and after getting mixed these signals are transmitted. So, when these signals are transmitted, then what happens in the transmission path? Here if the color receiver is there, then the signal is received here, and from here it is again with the help of decoder, this information which was encoded here red, green and blue, here is decoded and fed to red, green and blue electron guns, and from here the electron guns emit the red, green and blue signal, corresponding proportion of red, green and blue signal, and that is combined here to give the same kind of spot which was picked from here from the object. But this is how color TV works, but there is if there is compatibility, then this signal should be able to be displayed on monochrome receiver. Here if same signal after getting mixed in the combining matrix, if it is fed to the monochrome receiver, the receiver should be capable of displaying it in the corresponding black and white form. Similarly, if this signal which is monochrome signal is fed to the color receiver, here obviously decoder is there, but that decoder will not do anything because it is not RGB, it is the combined signal which is monochrome. So, this monochrome signal should be displayed in the corresponding RG and B mixture or proportion to give the same kind of spot here on the screen. So, if this is ensured, if this is possible, then we say the system is compatible. Now, we will just see what the natural light is. All of you know what the natural light is, but just will just have a overview of this, what the natural light is. When white light from the sun is examined, it is found that the radiation does not consist of single wavelength, but it comprises of a band of frequencies. It is not a single wavelength, it is a band of frequencies. There are so many frequencies. So, it is a band of frequency, a range of frequencies. In fact, white light is very small part of the large spectrum of electromagnetic waves. We all know this is only the visible spectrum, we call it the light, what we say it is visible spectrum, otherwise spectrum is very wide. So, which in total extend from very low to beyond 10 raised to power 25 hertz. The visible spectrum extends over only an octave, that only an octave of that is the visible spectrum, rest we can't see, it is out of the range of human visibility. Center around a frequency of order of 5 into 10 raised to power 14 hertz. The visible spectrum has been expanded and shown separately to demonstrate the range of colors it contains, and there we will have to note that various colors merge into one another with no precise boundaries. There is no precise boundary, colors merge into each other, and then after certain time we see that there is a new color which is formed. Here it is natural light, this is spectrum. Here we have radio waves, infrared, ultraviolet, X-rays and cosmic rays. Only a part of this only, this is visible spectrum. So, you can see this is just a fraction of the total spectrum. So, which is called visible spectrum, and it is expanded here. It starts from 780 up to 380. So, when the frequency we know frequency and wavelength, they are inversely proportional. So, 780, then around 700 we have red, then orange, yellow, green, blue, indigo and violet. So, if you read from this end, it gives you VIBGYOR, which is called VIBGYOR, very famous pronunciation VIBGYOR, which shows all the colors present in the visible spectrum. The compatible color television systems are the American National Television System Committee NTSC, the German PAL phase alteration by line, and the French system SECAM. Color perception, nature of light, visible spectrum, how we perceive the color, what is the nature of light, the visible spectrum, white light, which is equal to when entire visible spectrum reach eyes in suitable proportion, it is white light. VIBGYOR, I already have explained VIBGYOR, V for violet, I for indigo, G for green, Y for yellow, for orange and red for R for red. Range of wavelength it is extended from 380 to 780 nanometers. Human eye, what it can do, lens assembly it is, then has retina at back side of the eye where the images are formed. Light sensitive organs, we have certain organs which are very sensitive to light. From the help of these organs we sense the light, at what is intensity of light. According to theory formulated by Helmholtz, the light sensitive organs are of two types. There are two types of organs which are sensitive to light. Rods, these rods are the vertical rods. These are sensitive to the brightness of the object. So, they sense how much brightness is there. Whenever we see that it is very bright or it is not so bright, it is due to these rods that they sense it, that what is the intensity of brightness. And then we have cones, and these cones are sensitive to color. So, these are two parts, cones and rods, cones for color and rods for brightness. There are three set or group of cones. One set of cone detect the presence of red color in the object focused on the retina. The second set of cones perceive the blue color which is focused on the retina, and the third is sensitive to green color which is focused on the retina of the human eye. So, these three colors can be sensed, and what we see is the resultant of the combination of these three colors. Now, we will discuss the three color theory, mixing of colors. There are two types of mixing: additive color mixing and subtractive color mixing.